Thunderbolt is a hardware interface that allows for the connection of external peripherals to a computer. It uses the same connector as Mini DisplayPort. It was released in its finished state on February 24, 2011. Thunderbolt combines PCI Express and DisplayPort into one serial signal alongside a DC connection for electric power, transmitted over one cable. Up to 6 peripherals may be supported by one connector through various topologies. Due to its ability to tunnel PCI Express signals to an external port, it exposes all computers containing this port to DMA attacks unless either the port is disabled or if a hardware IOMMU is present and configured to block unauthorized transactions. Description: Thunderbolt was co-developed by Apple and Intel. It was commercially introduced on Apple's 2011 MacBook Pro, using the same Apple-developed connector as Mini DisplayPort, which is electrically identical to DisplayPort, but uses a smaller, non-locking connector. Though the Thunderbolt trademark was registered by Apple, full rights belong to Intel, which subsequently led to the transfer of the registration from Apple to Intel. Thunderbolt controllers multiplex one or more individual data lanes from connected PCIe and DisplayPort devices for transmission via one duplex Thunderbolt lane, then demultiplex them for consumption by PCIe and DisplayPort devices on the other end. A single Thunderbolt port supports up to 6 Thunderbolt devices via hubs or daisy chains. As many of these as the host has DP sources may be Thunderbolt monitors. A single legacy Mini DisplayPort monitor or other device of any kind may be connected directly or at the very end of the chain. Thunderbolt is interoperable with DP 1.1 compatible devices. When connected to a DP-compatible device, the Thunderbolt port can provide a native DisplayPort signal with 4 lanes of output data at no more than 5.4 Gbps per Thunderbolt lane. When connected to a Thunderbolt device, the per-lane data rate becomes 10 Gbps and the 4 Thunderbolt lanes are configured as 2 duplex lanes, each 10 Gbps comprising 1 lane of input and 1 lane of output. Thunderbolt can be implemented on PCIe graphics cards, which have access to DisplayPort data and PCIe connectivity, or on the motherboard of new computers with onboard video, such as the MacBook Air. The interface was originally intended to run exclusively on an optical physical layer using components and flexible optical fiber cabling developed by Intel partners and at Intel's Silicon Photonics lab. The Intel technology at the time was logically marketed under the name LightPeak, after 2011 referred to as Silicon Photonics Link. However, it was discovered that conventional copper wiring could furnish the desired 10 Gbps Thunderbolt bandwidth per channel at lower cost. Sumitomo Electric Industries started selling up to 30 meters optical Thunderbolt cables in Japan in January 2013, with U.S. company Corning Incorporated selling up to 100 meters optical cables from late September 2013. History. Introduction. Intel introduced LightPeak at the 2009 Intel Developer Forum, using a prototype Mac Pro logic board to run 2 1080p video streams plus LAN and storage devices over a single 30-meter optical cable with modified USB ends. The system was driven by a prototype PCI Express card, with 2 optical buses powering 4 ports. The technology was presented as having an initial speed of 10 Gbps over plastic optical cables, and promising a final speed of 100 Gbps in the future. At the show, Intel claimed that LightPeak-equipped systems would begin to appear in 2010. A YouTube video simultaneously published by Intel also showed LightPeak interfacing with HD cameras, laptops, docking stations, and HD monitors. Jason Ziller, head of the Intel Optical I/O program office, also demonstrated the internal components of the technology under a microscope and the sending of data through an oscilloscope. On May 4, 2010, in Brussels, Intel demonstrated a laptop with a LightPeak connector, indicating that the technology had shrunk small enough to fit inside such a device, and had the laptop send 2 simultaneous HD video streams down the connection, indicating that at least some fraction of the software firmware stacks and protocols were functional. At the same demonstration, Intel officials said they expected hardware manufacturing to begin around the end of 2010. In September 2010, Some early commercial prototypes from manufacturers were demonstrated at Intel Developer Forum 2010. Copper versus optical. Originally conceived as an optical technology, Intel switched to electrical connections to reduce costs and to supply up to 10 AW of power to connected devices. In 2009, Intel officials said the company was working on bundling the optical fiber with copper wire so LightPeak can be used to power devices plugged into the PC. In 2010, Intel said the original intent was to have one single connector technology that would allow electrical USB 3.0 and piggyback on USB 3.0 or 4.0 DC power. LightPeak aimed to make great strides in consumer-ready optical technology, by then having achieved a Euro-A connectors rated for 7,000 insertions, which matches or exceeds other PC connections, a Euro cables, that were tied in multiple knots to make sure it didn't break and the losses acceptable. A Euro and a Euro-A, you can almost get two people pulling on it at once and it won't break the fiber. A Euro predicting that a Euro-OE LightPeak cables will be no more expensive than HDMI. A Euro. In January 2011, Intel's David Perlmutter told Computer World that initial Thunderbolt implementations would be based on copper wires. The copper came out very good, surprisingly better than what we thought, he said. A major advantage of copper is the ability to carry power. The final Thunderbolt standard specifies 10 AW DC on every port. See comparison section below. Intel and industry partners are still developing optical Thunderbolt hardware and cables. The optical fiber cables are to run tens of meters, but will not supply power, at least not initially. They are to have two 62.5 micron wide fibers to transport an infrared signal up to 100 meters. The conversion of electrical signal to optical will be embedded into the cable itself, allowing the current MDP connector to be forward compatible, but eventually Intel hopes for a purely optical transceiver assembly embedded in the PC. The first such optical Thunderbolt cable was introduced by Sumitomo Electric Industries in January 2013. It is available in lengths of 10 meters, 20 meters, and 30 meters. However, these cable only retail almost exclusively in Japan, and the price is €20 higher than copper Thunderbolt cables. German company DeLock have also released optical Thunderbolt cables in lengths of 10 meters, 20 meters, and 30 meters sometime in 2013, similarly priced to the Sumitomo ones, and mainly retailing in Germany only. Following a September 11, 2013 press announcement of them being officially Thunderbolt certified by Intel, in late September 2013, U.S. glass company Corning Incorporated released the first range of optical Thunderbolt cables available in the Western marketplace outside of Japan, along with optical USB 3.0 cables, both under the brand name Optical cables. The cables have the advantage of being 50% smaller in diameter and 80% lighter in weight than comparable copper Thunderbolt cables, work with both the current 10 Gbps Thunderbolt protocol and the 20 Gbps Thunderbolt 2 protocol, so are able to work with all self-powered Thunderbolt devices. Being optical, the cables expand the current 3 meters maximum cable length offered by copper to a new maximum of 100 meters. Meaning peripheral Thunderbolt devices can be attached further away from their host device. The 10 meters cable was the first to be released, selling at around $300. They make the comparable per meter price to be around the same to that of standard copper non-optical Thunderbolt cables, with the company planning on eventually releasing 6 sizes altogether, in lengths of 4 meters, 5 meters, 10 meters, 30 meters, 50 meters, and 100 meters. Thunderbolt 2, at the physical level, the bandwidth of Thunderbolt 1 and Thunderbolt 2 are identical, and Thunderbolt 1 cabling is thus compatible with Thunderbolt 2 interfaces. At the logical level, Thunderbolt 2 enables channel aggregation, whereby the two previously separate 10 Gbps channels can be combined into a single logical 20 Gbps channel. Intel claims Thunderbolt 2 will be able to transfer a 4K video while simultaneously displaying it on a discrete monitor. Thunderbolt 2 incorporates DisplayPort 1.2 support, which allows for video streaming to a single 4K video monitor or dual QHD monitors. Thunderbolt 2 is backwards compatible, which means that all Thunderbolt cables and connectors are compatible with Thunderbolt 1. The first Thunderbolt 2 product for the consumer market was an ASUS motherboard, announced on August 19, 2013, but the first product with Thunderbolt 2 to be released was Apple's late 2013 Retina MacBook Pro, which was released on October 22, 2013. Early versions of Thunderbolt. It was rumored that the early 2011 MacBook Pro update would include some sort of new data port, and most of the speculation suggested it would be LightPeak. At the time, there were no details on the physical implementation, and mock-ups appeared showing a system similar to the earlier Intel demos using a combined USB LightPeak port. Shortly before the release of the new machines, the USB Implementers Forum announced they would not allow this, stating that USB was not open to modification in this way. However, in July 2011 Sony released its VAIO Z21 line of laptop with AA-OE Power Media Docker that uses the optical iteration of Thunderbolt to connect to an external graphics card using a combination port that behaves like USB electrically but also includes the optical interconnect required for Thunderbolt. Other implementations of the technology have begun in 2012, with desktop boards offering the interconnect now available. In spite of these comments and speculation, Apple's introduction came as a major surprise when it was revealed that the port was based on Mini DisplayPort, not USB. As the system was described, Intel's solution to the display connection problem became clear. Thunderbolt controllers multiplex data from existing DP systems with data from the PCIe port into a single cable. Older displays, using DP 1.1a or earlier, have to be located at the end of a Thunderbolt device chain, but native displays can be placed anywhere along the line. Thunderbolt devices can go anywhere on the chain. In this respect, Thunderbolt shares a relationship with the older access bus system, which used the display connector to support a low-speed bus. Apple explained that 6 daisy-chain peripherals are supported per Thunderbolt port, and that the display should lie at the end of the chain. In February 2011, Apple introduced its new line of MacBook Pro laptop computers and announced the technology's commercial name would be Thunderbolt, with these machines being the first to feature the new I/O technology. In May 2011, Apple announced a new line of iMacs that include the Thunderbolt interface. The Thunderbolt port on the new Macs is in the same location relative to other ports and maintains the same physical dimensions and pinout as the prior MDP connector. The main visible difference on Thunderbolt-equipped Macs is a Thunderbolt symbol next to the port. The DisplayPort standard is partially compatible with Thunderbolt, as the two share Apple's physically compatible MDP connector. The target display mode on iMacs requires a Thunderbolt cable to accept a video in signal from another Thunderbolt-capable computer. DP monitors must be the last device in a chain of Thunderbolt devices. Intel announced that a developer kit would be released in the second quarter of 2011, while manufacturers of hardware development equipment have indicated they will add support for the testing and development of Thunderbolt devices. The developer kit is being provided only on request. In June 2013, Intel announced that the next generation of Thunderbolt, based on the controller codenamed Falcon Ridge, is officially named Thunderbolt 2, and slated to begin production before the end of 2013. The data rate of 20 Gbps is made possible by joining the two existing 10 Gbps channels. This does not change the maximum bandwidth itself but makes using it more flexible. Thunderbolt 2 was announced by Apple in June 2013 on their developer conference WWDC to be shipped in the next generation of Mac Pro. Thunderbolt 2 is shipping in the 2013 MacBook Pro, released on October 22, 2013. Peripheral Devices. While Apple released their first computer to feature the interface in early 2011, it took some time for peripheral devices supporting the Thunderbolt interface to hit the marketplace, with initial ones not starting to hit retail stores until late 2011. Storage manufacturer Promise Technology was the first company to release large-sized RAID storage devices, with their Pegasus R4 and Pegasus R6 enclosures, however they were relatively expensive for the average consumer. Additionally, mass floods in Thailand where much of the world's supply of HDDs were made Euro heavily reduced hard drive production, so along with many products on the market generally, following the initial release, retail prices also increased further, contributing to a slow take-up of the devices. It also took some time for other storage manufacturers to release products, with most focusing on smaller storage devices, with speed being the goal rather than large-scale storage needs. Many of these devices were under 1 TB in size, with some also featuring an SSD for fast external data access rather than a standard HDD, mainly aimed at the professional user. Backwards compatibility with non-Thunderbolt equipped computers was also an issue, as most storage devices only featured 2 Thunderbolt ports for daisy chaining up to 6 devices together from a single Thunderbolt port. As of late 2012, very few other storage devices offering larger, double-figure TBs of storage, have started to hit the market, with Sonnet Technologies, Incorporated releasing high-end expensive professional units, and Drobo offering 4 and 5 drive enclosures, the latter featuring their own Beyond RAID proprietary data handling system. Other companies have focused on offering interface solutions, allowing older, usually slower, interfaces to be routed through a single Thunderbolt connection, meaning just one Thunderbolt wire had to be connected to the computer rather than many wires for each interface. Similarly, early on in July 2011, Apple released an updated monitor, Apple Thunderbolt Display, which featured many older interfaces, including Gigabit Ethernet, effectively making it the first product to be able to be used as a hub for this purpose. From mid-2012, manufacturers including LaCie and Drobo have started to include USB 3.0 connections in addition to the Thunderbolt 1S on some of their devices, though at the expense of removing the second Thunderbolt port. Vulnerability to DMA attacks. If Thunderbolt is used to extend the PCI Express bus, which is the main expansion bus in current systems, it allows very low-level access to the system. System bus devices usually have unlimited access to memory, and thus could be used to compromise security by performing DMA attacks. This issue exists with many high-speed expansion buses, including PC card, Express card and FireWire. An attacker could, for example, attach a malicious device. On connecting to a computer, the device, through its direct and unimpeded access to system memory and other devices, would be able to bypass almost all security measures of the OS and have the ability to read system memory which may contain encryption keys or install malware. It is, of course, always a risk to give untrusted parties physical access to a sensitive machine. An IOMMU, if present, can be used by an operating system that supports it to close a computer's vulnerability to DMA attacks. These attacks can be made rather inexpensively by modifying commodity Thunderbolt hardware. However, where Thunderbolt is used as a system interconnect, then the IP implementation runs on the underlying Thunderbolt low-latency packet switching fabric and the PCI Express protocol is not present on the cable. This means that if you use IP/OTP networking between a group of Macs, there is no threat of such DMA attack between them. Cost. In June 2011, the first 2-meter Thunderbolt cable from Apple cost $49. As an active cable, it includes circuitry inside the connectors. The cable has 5 wires, 1 for management and 2 unidirectional pairs, 1 for incoming and second for outgoing traffic. In June 2012, Apple began selling a Thunderbolt to Gigabit Ethernet adapter cable for $29. In the third quarter of 2012, other manufacturers started to release cables of varying length up to the maximum supported length of 3 meters, whilst some who were releasing storage enclosures started to include a Thunderbolt cable with their devices. In January 2013, Apple reduced the price on their 2-meter cable to $39 and announced availability of a shorter 0.5-meter cable for $29. Controllers, Intel Thunderbolt controllers, see also. References. External links, Thunderbolt Technology, a Euro official site.